Hello, stargazers and dreamers. Get ready for one of the night sky's most incredible shows, the Leonid meteor shower. This week, our planet is plowing through a cosmic trail of dust left by a comet, and the result is a beautiful cascade of shooting stars that seem to pour from the constellation Leo. The Lion. At its peak, we could see dozens of meteors every hour, tiny fragments of an ancient comet burning up in our atmosphere at breathtaking speed. So, in this video, we're going on a journey into the heart of the Leonids. We'll explore where they come from, why they're so special, and most importantly, how you can see them for yourself. The Leonids are more than just streaks of light. They're a direct link to the past. They originate from Comet 55P Tempel-Tuttle, which swings around the Sun every 33 years, leaving a trail of debris in its wake. Each November, when Earth crosses that path, these tiny grains slam into our atmosphere and vaporize in brilliant flashes of light. Over the centuries, the Leonids have produced some of the most dramatic meteor storms ever recorded, inspiring awe, fear, and scientific curiosity. This year, the conditions are fantastic. The moon will be just a thin crescent, meaning we'll have dark skies for perfect viewing. The forecast is about 10 to 15 meteors per hour, which is a really nice show. So, let's begin our journey through time and space, tracing the dance of cometary dust and the fleeting brilliance of shooting stars. To truly appreciate the Leonid meteor shower, it helps to understand the science behind it. So, what exactly is a meteor? A meteor is that flash of light we see when a tiny piece of space debris, often no bigger than a grain of sand, hits Earth's atmosphere at incredibly high speed. The friction heats it up, causing it to vaporize and create that bright streak we call a shooting star. A meteor shower happens when Earth passes through a whole stream of this debris, usually left behind by a comet. As all these particles hit our atmosphere at once, we see lots of meteors that seem to come from the same point in the sky. The parent of the Leonids is Comet 55P Tempel-Tuttle. It takes about 33 years to orbit the Sun, and as it travels, it sheds dust and rock, creating a long trail of debris. When Earth intersects this trail, the particles burn up in our atmosphere, creating the spectacular meteor shower we call the Leonids. But why the name Leonid? Well, if you trace the paths of all the meteors backward, they appear to originate from a single point in the sky. This point, called the radiant, is located in the constellation Leo. The Lion. Specifically, it's near the sickle shape that forms the lion's head. That's why we call them Leonids. The radiant rises around midnight and gets higher in the sky as the night goes on, which is why the best time to watch is in the early morning hours before dawn. One of the most amazing things about the Leonids is their speed. They enter our atmosphere at about 70 kilometers per second. That's nearly 157,000 miles per hour. This incredible speed makes them some of the fastest meteors we see, causing them to burn very brightly. They often leave behind persistent, glowing trails called trains that can linger in the sky for a few seconds. Sometimes they even produce fireballs, exceptionally bright meteors that can outshine the planet Venus in a typical year. You can expect to see about 10 to 15 meteors per hour under dark skies. It's a nice, steady show. However, the Leonids are famous for their occasional meteor storms, where the rate can explode to thousands or even tens of thousands of meteors per hour. These storms happen when Earth passes through an unusually dense part of the comet's debris trail. So why are some years stormier than others? The debris from Comet Tempel-Tuttle isn't spread out evenly. It clumps together in dense filaments, especially after the comet has recently passed by. The comet's 33-year orbit means that about every 33 years, there's a chance for a major meteor storm. The gravitational pull of planets like Jupiter and Saturn can also nudge these debris trails, sometimes pushing them right into Earth's path. Today, astronomers use all sorts of tools to study meteor showers, from simple visual counts to sophisticated radar and video cameras. Even citizen scientists play a huge role by reporting fireballs, which helps us map out the debris stream more accurately. All this data helps us understand the fine details of these cosmic dust trails and predict future showers. The Leonid meteor shower has a history that's as dramatic as the display itself. One of the most legendary events in astronomy is the Great Leonid Storm of 1833. On a November night, the skies over North America erupted. People reported seeing tens of thousands of meteors per hour. The sky was so full of falling stars that many genuinely believed the world was ending. It was a terrifying and awe-inspiring sight that helped kickstart the scientific study of meteors. Some accounts even suggest the rate was over 100,000 meteors per hour, a true celestial downpour. The 33-year cycle held true, and another major shower occurred around 1866. But the most spectacular storm of the modern era was in 1966. On November 17th, observers in North America were treated to an unbelievable display. At Kitt Peak Observatory in Arizona, astronomers reported rates as high as 40 meteors per second for a short period. Imagine that the sky was literally raining fire. It remains one of the most intense meteor events ever recorded. More recently, in the late 1990s and early 2000s, the Leonids put on another series of impressive shows. As Comet Tempel-Tuttle made its pass through the inner solar system, the years from 1998 to 2002 saw greatly enhanced activity, with rates reaching hundreds or even thousands of meteors per hour in some locations. These events allowed scientists to study the complex structure of the debris stream, finding multiple filaments and subpeaks in activity. These incredible storms are historically important. The 1833 storm, for example, proved that meteor showers were a recurring, predictable celestial event, not just random atmospheric phenomena. The later storms helped us refine our models of comets, their debris trails, and how planets influence them. Beyond the science, the Leonids have had a huge cultural impact. For centuries, meteor storms were seen as omens or divine messages. The 1833 storm, in particular, was captured in art, folklore, and literature. In our time, meteor showers bring people together: amateur astronomers, photographers, and families, all looking up at the sky in wonder. For many, seeing a meteor shower is a profound experience, a brief, beautiful connection to the vast cosmos around us. So, how can you watch the Leonids this year? The good news is, it's easy. First, you need to get away from city lights. The darker your location, the more meteors you'll see. A park, a field, or any spot with a clear, open view of the sky is perfect. The best time to watch is after midnight, with the peak viewing hours being in the early morning, just before dawn. This is when the radiant in Leo is highest in the sky, meaning more meteors will be visible. The shower is active for several days, but the peak night is when you'll see the most action. Check online for the exact peak date for your location. You don't need any special equipment, no telescope, no binoculars. In fact, your naked eyes are the best tool because they give you the widest field of view. Just lie back and look up. A comfortable reclining chair or a warm blanket on the ground is a great idea since you'll be looking up for a while. Give your eyes time to adjust to the darkness. It takes about 20 to 30 minutes for your eyes to become fully dark adapted. So put your phone away. The bright screen will ruin your night vision. Be patient. There might be lulls where you don't see anything for a few minutes, followed by a sudden burst of activity. And finally, remember to dress warmly. November nights can get cold, so layer up, bring a hat, and maybe a thermos of something hot to drink. Comfort is key to enjoying the show. Watching a meteor shower is a fantastic experience. It's a reminder of our place in the universe and the dynamic, ever-changing nature of our solar system. Each one of those streaks of light is a tiny piece of a comet that has traveled for billions of miles, ending its journey in a fleeting flash of glory. So get out there, look up, and enjoy the show. Thank you for joining me on this cosmic journey. I hope you get to see some amazing Leonids this year. If you enjoyed this video, please give it a thumbs up and subscribe for more adventures into the cosmos. Clear skies.